All right, chapter 8.7, our last section in chapter 8, complex numbers. So we want to go ahead and check out what is a complex number, where it come from, and all that kind of good stuff there. So to demonstrate this, I'm going to go ahead and just do this small example here, and that is x squared plus 1 equals 0. Okay, so we want to go ahead and solve for x here and see how this is going to work. And let's see if my little board's going to work here. And there it is. Okay, so what we want to do here is let's go ahead and solve for x. I'm going to subtract 1 to both sides. So I get x squared equals negative 1. And now I want to get rid of my square, so I'm going to do the opposite of squaring, which is square roots. So x equals, now anytime that we take the radical, we always want to do plus or minus the square root of negative 1. Okay, so let's see if we can make sense of this. All right, going back to what is a radical, such as, say, if I said radical 9. Well, again, this means what number do I square to get 9? Okay, that's what a square root means. So in this case, what number do I square to get negative 1? Okay, well, if we try 1 squared is a positive 1. If I try negative 1 squared, well, that's also going to be a positive 1. And you can try 100 million billion other numbers, and you're never going to get negative 1. So the problem now is, how do we handle the square root of negative 1? And that bothered for many mathematicians long time ago. So now we have a little story here. So mathematicians got really scared, such as this one right here. They didn't know what they were going to do. They were wondering what to do with the square root of negative 1. But then there was an idea. They said, oh, well, basically we know that the square root of negative 1 is not possible, but we have to be able to at least rewrite it in something that that can be useful. So then we said, okay, well, let's let the square root of negative 1 equal I. Everyone said, they're like, that sounds super radically cool. So then everyone went back home and they were able to sleep nicely. And that's how the complex numbers came about. Maybe. That could be a little distorted, but you can look it up on Google. Okay, but let's actually do our first example, though. All right, here we go. So example 1, we're going to simplify square roots with negative numbers. So let's just remember that the square root of negative 1 we're going to call I. Me, matey. Okay, so anytime that we have a square root of a negative number, we're going to call it I. All right, so check this out right here. So we have the square root of negative 100. Okay, so let me just show you technically what this means is the square root of negative 1 times the square root of 100. Okay, so that's what that means. I mean, if you multiply negative 1 times 100, you're going to get negative 100. So the square root of negative 1, again, like we just said over here, all right, is I, and the square root of 100 is 10. Okay, but we don't want to write it as I10. We want to write the coefficient first as our number, so we want to say 10I, and that's that. This right here, by the way, I is called a complex number, or we also call that an imaginary number. And it's imaginary, or we call it complex, because it doesn't exist. There is no such number. It's not possible to take the radical, the roots of a negative number. So that's why we call it, it's imaginary, or and the name for that is complex. Okay, over here, we have negative times a negative square root of negative 36. So we can think of this as negative times the square root of negative 1 times the square root of 36. Okay, well, the square root of negative 1 is I, so that's negative I, and then the square root of 36 is 6. So let's rewrite that so it looks more appropriate, negative 6I. Okay, so probably, as you can see, it's kind of tedious to keep writing the square root of negative 1. So basically, anytime that you have a negative radical, just stick on the I, and then just treat it as if it was going to be positive. Okay, now let's look at C. The square root of negative 2? Well, that's just going to be simply 2i. Why? Because the square root of negative 1 times square root of 2, square root of negative 1 is I, and then just square root of 2. Oh, sorry, square root of 2. Okay, now check this out though. Square root of 2i kind of looks like this, square root of 2i. Do you see the difference there? This one, the radical is only underneath the 2. In this problem, the radical is underneath, or the 2i is underneath the radical. Okay, these actually are not the same. Okay, in this problem right here, the I should be on the outside of the radical. So anytime that we have roots in our answers, we actually want to put the I in front. Okay, so that we don't have this problem right here where, well, is the I in the radical or is it on the outside? So the way that we take care of that problem is we just say I and then times radical 2. So kind of that's the way that you want to write it when we have a radical answer in there. All right. All right. So let's see. This is square root of negative 1 times the square root of 54. And again, we can rewrite this as I square root of 9 times square root of 6. And square root of 9 is 3, so 3i radical 6. Cool beans.